The next question of Code Forces round 918 Div 4 is greetings.
So in this question, we are given positions of people, right? Each person is given that initial position of that person is AI, and that person wants to reach a position called BI.
Yeah.
It is also given that AI will always be less than BI.
Yeah.
Right? Now, each person is actually moving with a speed of 1 unit per second towards their destination, towards BI. Right? Now, in this process, they are saying that if any two people meet at a point, right, in this whole process of moving towards BI, then they greet each other, right? And what they are asking us to do is find out how many greetings will be there in this entire journey. Right? It is also said that if a person reaches his position, end position BI, after reaching also, if there is some collision with some other person, then also a greeting will be happening. At the end, we should tell total number of greetings that will be happened in between and people. Right? Each person's AI and BI are given to us, which is starting and ending positions of that particular person. Looking at the constraints say that T is the number of test cases, which is in the range of 1 to 10 power 4. We are given N, total number of people, which is again in the range of 1 to 2 into 10 power 5. Then we have AI, BI, which are positions of the person, which are in the range of minus 10 power 9 to 10 power 9. And it is given that AI will always be less than BI. And it is also given that our N value, sum of N value over all test cases will not exceed 2 into 10 power 5. Those are the constraints of the question. And also, all AI, BI elements are distinct among all the N values. Right? We don't have duplicate AI and BI in the question. So this is the constraints.
So in this question, firstly, let's observe when will actually a greeting happen. Then let's break it down to solve. Observations firstly. So we are given starting point where the person starts and the ending point. So S1, let S1 be the starting point of first person where he starts, and E1 be the ending point of the first person. And we know that S1 will be lesser than E1. This is guaranteed. And every S1 point is distinct. Similarly, every E1 point is distinct. So basically, even S1 and E, like even S and E will be distinct, including all S and all E. If we add them in a set, then every point is distinct. Yes. That's what is guaranteed.
Yes.
So now let's say second person's start is S2, E2. Third person's start is S3, E3. So on till nth person's start point is Sn, end point is En.
Yeah.
So now, before coming into this, let us analyze it with respect to ranges. Firstly, we know that every person is moving with constant speed. So it is 1 unit. That is, it is completely uniform. Right? So because everyone are moving with same speed, we can for sure guarantee that while they are moving, they'll never intersect. As everything are initially distant, so as they are moving, they'll never intersect. So now let us see when can they intersect. Firstly, let the range be something like this. P1 started at some point here and he ended at some point here. Now let's not care about the value. So now let us just consider he started at some point over here and ended over here. Now if P2 starts at some point here, percent 2, I mean, we are just deducing when can two people meet. Because when they meet, then only they'll meet. So that is why, let's deduce it for two people only. This is P1 start and end. So let me write it as S1 as per how we wrote here. And this is E1 endpoint. And this is second person start and endpoint. Now in this scenario, can they meet?
No.
No, right? Because these two people are starting at this point and they are moving with constant speed. That means the difference between their distances will always remain the same.
Yes.
Until second person reaches E2. So from that we can observe that they can never meet. So let us take one more scenario. That is, even in this scenario, the claim is they won't meet. Right? That is, this person, both of them will move with constant speed, and he'll end up here, and this guy will move till here. But if one of the range is completely lying inside the other range, then they'll meet. So let's see why. So this is, let's say, start point of second person, end point of second person. And I won't write the reverse case, that is S2 here and S1 here, because that will also be the same. Both are symmetric. So now, in this case, if we see both of their differences, both of their distance difference will remain same until S2 reaches this. After that, S2 will stop here, but S1 for sure have to cross this point. That means he'll for sure reach S2 at this point. Right? First person will reach second person at this point.
Yes.
So to calculate number of greetings, we can just find out how many such points are there. So basically, we can just find out how many people will cross a particular person's destination. Once we know that, then it's just sum of all those crosses happen. Right? So for that, let us do a thing. So basically, for a cross to happen, the following should hold. That is, let's say uh, S1 cross is happening for E1. Okay, let's say cross is happening for E2. For E2 to get crossed, E2 should be E2 should be lesser than E1. Right? And however, they won't be equal because constraints guarantee. And other criteria should be starting point S1 should be lesser than S2. Right? Then only they will intersect. Right? So now, because this is true, what we can do is to firstly ignore this. We can sort the array with respect to first value. Right? So if we sort the array with respect to first value, uh, now let's say all these are sorted, and I'll just represent them as follows: S1, S2, so on till Sn. Now, assuming that these are sorted, so though I number them 1, 2, 3, assume that these are sorted. After sorting, it looks like this.
Sorted only based on start.
Only based on start time. So only based on this. So once we sort, is this condition already handled?
Yes.
It is already handled. We know that any higher indexed person will have starting points value greater than any lower indexed person. Now, because this is handy, our only aim is to satisfy this condition. Right? If we look over, all these elements should hold the following. Right? That means for any higher person, if there exists a lower person whose endpoint is greater than the higher person's endpoint, then we can say that this higher person will cross that lower person. Okay, no, this lower person will cross the higher person because his endpoint is smaller and his is lower. So we just need to find out. Now it just came down to finding out inversions in this angle. So basically, we just need to find out how many inversions are there in this. That is basically how many endpoints are there which are greater, basically for a fixed point. Let's say this is 3. So for this 3, we should find out how many endpoints are there before 3, whose value is greater than the current one.
So basically, an inversion is nothing but number of I, j
Number of
pairs,
I, j pairs,
where I is less than j
yeah, I is less than v,
and
and ei should be greater than.
yes.
So if we just count out how many these pairs are there, those many greetings will happen.
Yes.
Because those many crosses will happen. So to count number of inversions, there are many ways to do that. One way is you can just use merge sort. While merge sorting them, we can calculate the inversions. One more way is we can use Fenwick tree with coordinate compression. That is one way to count inversions. Fenwick tree or segment tree, anything. Fenwick or segment with coordinate compression. And one more way, we can even use ordered set. So in C++, we have PVDS. In few languages, they provide inbuilt ordered set. We can use that. Or we can build our own ordered set and then use it. So this way, we can solve the problem just by counting the inversions of this. So if we look over the time complexity, it would be big of n log n. Firstly, we are sorting it with respect to first element. That will cost us n log n. And again, here to count inversions, we apply merge sort or Fenwick tree or ordered set. All of the three things will have a time complexity of n log n. So that is why you can say it's n log n. And space complexity, it depends on how you implement. So we can implement it in a space of big of n. Assuming we are doing merge sort. Because we create a temporary array, we can say it's big of n. These all are persistence. And it's and n depends on test cases here. That is summation of n will be less than or equal to 2 into 10. That means this will cost us. That means we can assume there is one test case with n 2 into 10. So 2 into 10 per 5 log 2 into 10 per 5 will be less than 10 per 8 iterations. So this is sufficient to pass in 1 second of t. So provided TL for this is 5 seconds. So it's more than sufficient to pass in more than sufficient to pass in the given t. So this way we can solve the problem.